Welcome back. This is Module 5 of the first robotics competition, Introduction to Java Programming. My name is Tom Dunn, and I'll be your instructor for this module. So what is inheritance? Inheritance implements an is-a relationship between two classes. In the is-a relationship, you're going to have a more generic or general class, and you're going to have a more specialized class, which is a more specific kind of the base class type. And that forms the basis of inheritance. Suppose you already have a class that has some behavior that you want to use, but you want to change some of that behavior. You could create a brand new class and rewrite all of the behavior that you want to keep, but that's slow and tedious and risks introducing errors. So what we do with inheritance is we create a derived class that has all of the behavior and all of the attributes of the class that it's derived from, but it can also have new behavior, and it can replace some of the original class's behavior with new implementations. This gets a little bit tricky. Remember way back, I think it was in Module 2, I mentioned that a class is a specification. It declares a contract that every instance of that class has to follow. When I create a new derived class, which is a more specialized version of the class, I still have to follow that contract, which means I can do no less than the contract requires. I can add new features, but I cannot take features away by inheritance. So there's a little bit of naming confusion with inheritance. The class that is derived sometimes is called a subclass, sometimes it's called a child class, sometimes it's called a derived class. It's all the same thing. The thing that you derive from is sometimes called a parent class, sometimes it's called a superclass, and sometimes it's called a base class. And I am guilty of mixing up those terms myself, but they all mean the same thing. So a subclass, child class, derived class all mean the same thing. A parent class, superclass, or base class all mean the same thing. So how do we declare that one class inherits from another? In Java, we use the extends keyword, and the extends keyword is a reserved word in Java. One of the things that we can do when we create methods in a derived class is override the methods in the base class. We already touched on overloading methods. So with overloading methods, the parameter types and the name of the method have to be the same. Overriding is a little bit different. Overriding means you have to have a method in a derived class that has to have the exact same signature. It has to have the same name and the same parameter types. Anytime we invoke a method in an instance of a derived class that's been overridden, we will actually invoke the overridden method. It doesn't matter whether the object reference we're using to reference the method is a reference to the base class or a reference to derived class. What matters is what the reference is pointing to. So if the address stored in an object reference is the location in memory of where a derived class lives, we'll always get the overridden method. And that's incredibly powerful. And we'll go over that a little bit later. So don't worry if it's a little bit murky right now. Just remember, overriding is not the same as overloading. They're similar, but they're different. So constructors. A constructor is responsible for initializing an object when it's created. Constructors are not inherited and cannot be overridden. But the superclass constructor can and should be called in each derived class's constructor. The Java provided default constructor does call the superclass's default constructor, and that's necessary to make sure that all the attributes get initialized. Imagine you have some attributes that are private, which means they're only accessible inside the current class, and then I derive a new class from that base class. My new derived class cannot access those private data members in the parent class. It's not in the same scope. So the only way to guarantee they get initialized correctly is if the constructor of the derived class invokes the constructor of the parent class or superclass. The constructor's job is to initialize all the attributes. So here's an example of inheritance. In this case, I have a class, bird. Bird is public. Bird has a constructor. I know this method is a constructor because it has the same name as the class itself. And that's it. That's the end of the class declaration. For my derived class, I say class sparrow extends bird. So I would read that sparrow is a bird. It's a specialization of bird. Sparrow has its own constructor, and its own constructor calls the base class constructor. So this method called super is a reserved word that invokes the superclass's constructor. And if your constructor takes parameters, you can pass parameters to the super method. So you can see the syntax for the base class is unchanged. The base class is just a regular Java class. It's the derived class that has to add this special property on its declaration to notify Java that it is a subclass extending from or deriving from bird. Another interesting thing to note, in Java, a class can only derive from one and only one class. Another interesting thing to point out, remember when we were going over operators, I mentioned that every class has a method equals, which you can override. Now I've explained what overriding actually is. Every class in Java is inherited from the class object, and the class object actually has that equals method in it. So every single class in Java has a single rooted inheritance tree. Everything derives from the object class. So now let's talk about an abstract method. A class defines a type, and a type is a contract or a specification. It tells you all the things you can do to and with that object. Abstract methods are nothing more than method signatures established in a base class without any implementation at all. There is no Java block, no open or close curly braces for an abstract method. What they do is they declare that this class will have this method, but I'm not going to give it to you right now. It has to be overridden before any objects can be instantiated. And we specify an abstract method with the abstract keyword, so that's another reserved word. An abstract class is a class that has at least one abstract method. Obviously, if the class declares that it has to have a specific method, but it does not provide any implementation of that method, we cannot instantiate the class until we derive a subclass from it. Then we can instantiate the subclass, but we still can't create instances of the parent abstract class. So why would we do this? What does this actually accomplish? What we're doing is we're implementing one of the four principles of object-oriented programming, abstraction. We're abstracting the common behavior out and putting it in a base class. But some of the behavior may not be implementable until we know more about the derived class. So we're declaring that our contract has some behavior to be provided later. And we'll see that in the FRC library. So it's important that you at least understand the basics of what this is. So here's an example of abstraction in operation. I have a class, Simple Robot. Simple Robot is an abstract class because I put that abstract keyword on the class. That means it contains at least one abstract method. So here is that abstract method. I've declared a method, operator control, returns void, and it's abstract. That abstract means I end the declaration with a semicolon. I do not end it with an open and close curly brace and a bunch of statements inside the Java block. So that's the end of my class. I did not declare how operator control is going to work. And that makes sense because in my simple robot, which is the very generic version of a robot, I don't know what it's going to do in operator control. That has to be provided by the more specific concrete implementation. So I have another class here named George. George is a simple robot. So my robot George is going to override operator control. You can see it has a method with the exact same signature, the same name and the same parameter list, and the same access specifier, only this time it does have a Java block. So it has an open and close curly brace that delineate the Java body, and inside the body I have a while loop. While is enabled and is operator control, ... I've also put a Java annotation here. I haven't gone over what a Java annotation is, but trust me, you will like them, so plan on using them. But basically, it's a command to the compiler that says, this method, operator control, must override something in the base class simple robot. What if I misspelled operator control? Instead of creating a new method in addition to the abstract method, this will throw an error right then and there and say, hey, wait a minute, you said this was supposed to override something, but its signature does not match exactly one of the methods in the base class. Therefore, it's an error. So that's what the annotation does. And we'll see this pattern over and over again in the FRC Java library, where an abstract declaration for simple robot or iterative robot or PID controller or motor controller, and we'll see many examples in the FRC library where they've taken advantage of abstraction to provide a consistent contract or specification to a class without having to know the specific implementations of how your particular robot works. So we mentioned inheritance implements an is-a relationship. An instance of a subclass is a superclass and can do anything the superclass can do. Remember, inheritance implements substitutability. The derived class can be substituted for the base class. What that means is you can cast a reference of one type to a reference of a different type if they're related via inheritance. You can also store a reference to a subclass in a reference to the superclass. So if I have a variable of type simple robot, I can store a reference to George in a variable of type simple robot because George is a simple robot. George can do anything a simple robot can do. George can do a few things simple robots can't, but it can at least do everything that a simple robot can do. That leads us to polymorphism. The actual behavior that is invoked depends on its place in the inheritance hierarchy. By its place, I mean the instance of the object that I'm working with. So overriding together with casting creates polymorphism. Polymorphism is the fourth of the four principles of object-oriented programming. So polymorphism, in a nutshell, means a class can take many forms. So here I've got a class, animal, up in the upper left corner. Animal is an abstract class that has a method, makeNoise, which returns void and is abstract. So I'm saying every animal is capable of making noise. Now I'm creating a new class, frog. Frog extends animal, and frog overrides the method makeNoise, and it actually provides a method body. Its method body invokes the method croak, so frogs croak. We also have dog. Dog extends animal. It also overrides the makeNoise method, and it invokes the method bark. And I also have class cow. Cow extends animal. So cow is an animal, and it overrides the makeNoise method, and its overridden makeNoise method invokes moo. So now I have a method called vocalize. This method vocalize takes an animal as a parameter, a reference to an instance of an animal object. We know the animal class is abstract, so we can't have instances of animal, but we can have instances of subclasses of animal, because those are concrete classes. They have implemented the abstract methods. So what happens when I call the makeNoise member of A? Well, that depends on what A is. If A is a frog, it's going to croak. If A is a cow, it's going to moo. If A is a dog, it's going to bark. So you can see the actual behavior implemented by A depends on the place that A exists on the object inheritance hierarchy. So that's polymorphism. One object, A, can have many forms. And I can pass an instance of a frog or an instance of a dog or an instance of a cow to the method vocalize as its parameter A because they're all related through inheritance, which means I can typecast a reference to a cow into a reference to an animal. So what's an interface? An interface is a class. Enough said. We're done. It's a little more complicated than that. An interface is a special kind of abstract class that defines an object's public interface, that is, its contract with the outside world. The interface defines a type, because it is a class and all classes define a type. All methods in an interface are abstract, which means an interface in Java cannot have any method bodies. It also cannot have any data attributes. So there's no data attributes in an interface, and there are no method bodies. There are only abstract method declarations. Unlike inheritance, which uses the keyword extends, interfaces use the keyword implements to define a class that fulfills the contract. It still implements inheritance in that it is going to derive from the interface. So let's look at an example of an interface. The first couple lines are declaring a brand new interface describable. One of the coding conventions that we follow in Java is that all interfaces have a name that ends in the suffix able. So you'll see interfaces like comparable, sortable, serializable. So this is another implementation of that coding convention. Also, like with all classes, we name our classes with a capital letter. So this class, describable, declares two abstract methods, getDescription and setDescription. We know that they're abstract because they're inside an interface, and all methods inside an interface have to be abstract. Now we're going to create a concrete implementation of that interface. So book is a describable class. It implements the describable interface, which means it provides concrete implementations of all the interfaces that the describable interface declared. It has one data member, description, which is a string, which is private. It has a constructor. Book is the constructor because it has the same name as the class, and it ensures that the description is initialized to an empty string. In Java, all primitive types are initialized to 0 or false, and strings are initialized to an empty string. All other objects are initialized to null. And it now overrides the two methods that were declared in the base class, describable. They override it because they have the exact same signature as the methods that were declared in the base class. So getDescription returns a string and is public and takes no parameters. SetDescription returns void, is public, and takes one string object reference as its parameter. And you can see for the getDescription, it returns the description member of this. It's returning its own attribute. And setDescription is initializing or assigning the description member of this to a new instance of a string class, and we're passing it the parameter desc. So description is a brand new string in a different memory address on the heap that's going to contain the contents of desc. One of the interesting things in Java, I mentioned with inheritance, a class can only derive from one other class. And that is true. In regular inheritance, you can only use the extends keyword with one parent class. That's not true with interfaces. In Java, a class can implement as many interfaces as you want. So a single class could implement describable and sortable and comparable and serializable. It can implement as many interfaces as you want. Each one of those interfaces declares a set of methods that you must implement because those are abstract methods, and abstract methods are left to the derived classes to provide the invocation body. But if you implement more than one, you just have more methods you have to implement. But what that means is I can pass a book as a parameter to any method that takes a describable as its parameter. Since book is a describable, book is substitutable for any describable. So anywhere I use a describable, I can use a book. That becomes incredibly powerful in FRC. Imagine, for example, you're writing the field management system for a FIRST robotics competition. You're going to initialize the field, and you're going to tell every robot in the field that they're going to start autonomous. You don't know what each robot is going to do as part of its autonomous code, but you don't really care. The field management system does not care what the robot does. What that means in Java terms, it does not care what the implementation of the autonomous code actually does. The statements that occur in the autonomous method are irrelevant to the field management system. All the field management system cares about is that every FRC robot has an autonomous method. That means that it can enter autonomous mode, do whatever methods it's going to do, and then exit autonomous mode when the 15-second timer expires. So that implements two of the key principles of object-oriented programming. That implements abstraction because we've abstracted out the autonomous method from the more specific implementations into a more generic base class. And we've also implemented polymorphism because the actual behavior that is exhibited when we invoke the autonomous method on a robot, George, could be different than the behavior exhibited when we invoke the autonomous method on a robot, Phantom Telepath. So we can see inheritance is complex, but inheritance gives us a tremendous amount of power in programming. And in fact, inheritance is probably the one thing that makes object-oriented programming so powerful that it's still used today, and it's gaining in popularity today. So that pretty much wraps up this module on inheritance. Hopefully it's whet your appetite and you're going to go back and read more tutorials on inheritance. But even if you don't, I'm hopeful that you now have a good, solid foundation that you can use to understand what's going on when we start getting into some of the FRC programming in the next class. Thanks for attending.